Okay, let us practice how to do the four-step process using some example questions. Ace wants to estimate the proportion of Napa Valley College students who plan to attend the commencement ceremony in May. She interviews a simple random sample, which we can call an SRS, of 50 out of 5,000 students in her school and finds that 36 plan to go to the commencement ceremony. Use the four-step process to construct a 95% confidence interval for the true population proportion of Napa Valley College students who plan to attend the commencement ceremony in May. I want to ask myself whether I'm talking about proportions or means. I want to know if I'm talking about one sample versus two samples, and then I want to know whether I should be estimating a parameter or I should be running a hypothesis test. Now, because I said I want to estimate the proportion, that's a confidence interval right there. And I have one simple random sample. That's one sample. So I'm doing a confidence interval. It tells me it's a proportion, and I have one sample. So that tells me I'm going to be doing proportions, confidence intervals, one sample. So then I can go to the rubric and use that as a guide. I'm going to begin by using the state portion. And in the state portion, you need your confidence level, your parameter, and in context. Okay? So we want to construct an interval. What kind of interval? We want to construct a 90% confidence interval. And what are we constructing it for? We are constructing it for the true population proportion of Napa Valley College students who plan to attend the commencement ceremony in May. So we put that all together. Okay, let's double check that I have everything. I have my confidence interval level. I have my population parameter, it's P, and I have the parameter in context. So that is the population proportion, and then here is my context. Now I can move on to the plan. This is where I'm checking my conditions. And when I'm checking my conditions, I'm looking for random, independent, and normal to make sure I can use those normal probabilities. Looking back at the prompt that we're given, it does say that it's a simple random sample, which means we can say random as stated. Next, we want to check the independent condition, and this is verifying that the sample is less than 10% of the population. And the reason that we do this is so we don't have to give information as to whether we're sampling with or without replacement, because the larger sample you get, the more likely you are to repeat individuals, and so we want to make sure that each individual value is unique. The way in which I check this is I look at the sample size, so 50. 50 is less than 10% of the population. Well, what is the population? We want to talk about this in context. So we're talking about Napa Valley College students. And in this problem, we're actually given that there are 5,000 students. So 50 is less than 10% of the 5,000 Napa Valley College students. Then we want to check our normal. And the way in which we check normal for proportions is we verify that the successes and failures are both greater than 10. And we're using p hat here because we don't know what the population value is. We need to estimate it. So we need to check that our successes and our failures are greater than or equal to 10. And we can't just say this. We need to give numbers. So our population size was 50, and then our proportion was 36 out of those 50, which means that our proportion of success is 36, which is definitely greater than 10. And then our failures is going to be 1 minus that 36 over 50, which is going to be 14, which is greater than or equal to 10. So because our conditions are met, we can move forward with normal calculations. Now we go to, let's verify that we have done everything we need in this statement, in this plan portion. We've checked the random condition, we've checked the independent condition, and we've checked the normal condition with both successes and failures by showing the numbers. Now we can move on to the do, and this is where we use StatCrunch. In StatCrunch, we're going to go to Stat, Proportion Stats, One Sample with Summary. I'll write that in yellow. You do not need to include that on your test. This is just me telling you what the steps are, and you can find that on the rubric on the second page or on the first page in the do. I write it multiple places. For this, I need to calculate what p hat is and what the sample size is. So I've got the sample size was 50, and then p hat was 36 over 50, or 0.72. I also need to find the interval. When I do stat, proportion stat, one sample with summary, I enter the number of successes. There were 36 out of my 50 that said they were going to go to the commencement ceremony. And I want to make sure I click that confidence interval box in StatCrunch and I change it to the level what the question asks. This question asks for 90%, so I'm going to do a 90% interval and then I compute. And then I'm looking at that L limit and U limit. That's lower limit and upper limit. The lower limit was 0.616 rounded to 3 decimal places and 0.824 rounded to 3 decimal places. Let's verify I have everything that I need in the do. I've got my N, I have my P hat, and then I have my confidence interval, the lower and the upper. So we're good. Now we can move on to our conclude. We make our conclusion connecting the confidence level, the parameter, and the interval. And the way that we do that is we say we are, however confident we are, so we are 90% for this, confident that the interval, and we write our interval, captures the parameter, so that's P, the true population. Population what? The population proportion, that's our parameter that we're talking about, of, and then what's the context? So we go back to our sentence, and it's actually the same thing that you wrote in the state. Napa Valley College students who plan to attend the commencement ceremony in May. Let's double check that we have everything in our conclusion. We included our confidence level, we included both values of the interval, we included the parameter and what the parameter was, and then we included the context. And so we're good. This is our 4-step process for the confidence interval.